Checkpoint Module 6 solutions, video solutions, section 4.1. We were asked to use transformations on this function to construct that in the order of operations. I cannot stress enough. So the first transformation is on x, meaning 2 to x plus 2. So we have to shift the graph 2 units to the left. This point will be translated 2 units to the left. It becomes -2, 1. The original function has to pass through 0, 1. So this is a left shift of 2 units. And now we shift the graph down 1, which means the horizontal asymptote, which is y equals 0, has to be shifted first to -1, and then the graph. This point will move down 1 at -2, 0. And the horizontal asymptote has to be graphed, like all asymptotes have to be graphed, always. Here we're asked to identify which of the situations is better. $6,000 invested at this percent the interest is compounded 4 times a year, quarterly, and for 40 years. All I have to do is just plug it in, the principal, the rate, number of times it is compounded per year, and n times 4, or n times t, is 4 times 4, which is 16. Plugged it in the calculator. Be careful with parentheses and the power. Same thing here, but they were different. So the rate is now 0.083, and it's just semi-annually, which means twice a year. And we get this by comparison. This is a better deal. So compounded 4 times at this interest rate is a better deal for us. We were given these 3 points on the graph, and we realized that f of x equals e to -x, which is 1 over x. 1 over e to the x power, I meant to say. So when I plug in -2, I get this. When I plug in -1, I get this. When I plug in 1, I get this. Here we're just asked to plug in, keeping in mind that x equals 0 represents the year 1986. And we were asked to determine what is still in the atmosphere in 2066, which is 80 years later. Since it is more than 100 kilograms, it is not safe yet. The next section, we are asked to look at some equations, log equations. And always remember, the base raised to this power equals this number. Always counterclockwise. And change 125 into 5 to the third. Obviously, y has to be 3 because 5 to y has to be 5 to 3 to the third power, so y must equal 3. Here we are asked to change this into a logarithmic equation. So remember, the base is always the base of the exponential and the log. Counterclockwise, 15 squared equals x. 15 squared equals x. Here we're asked to solve. 3 to y equals 1 over x, 1 over the square root of 3. So 3 to y, this has to be replaced by 3 to -1/2. The square root is 3 to 1/2 because it's in the denominator. The power is 3 of 3 is -1/2. Again, the same concept. Bases are the same. Exponents have to be the same. Here we're asked to graph this function using transformations. First, I have to identify the domain. In all these situations, when the function does not have all real numbers as domain, we always have to start with the domain. And you see, as we discussed a few minutes ago, on a different function, the vertical asymptote, which is x equals 0, gets shifted 2 units to the right first, before this point jumps to 3. Okay, so all this is shifted, but first the vertical asymptote is shifted from x equals 0 to x equals 2, and 1 goes 2 units to the right, so this is the new graph. Here, the same thing, we have to determine the domain. So -x has to be greater than 0, which after we multiply both sides by -1, we get x less than 0. So then this is basically a reflection with respect to the y-axis. Okay, so this point goes here at -1, 0. Domain, like we discussed 3 times already, 7 minus x. I have to multiply, and this is the domain. Multiply by -1. Same thing here. We just talked about the previous section. X squared minus 4x minus 12 has to be positive. And remember the table that I recommend. you factor and you study the sign. These two have a positive slope, negative, positive, negative, positive. You multiply two negatives, you multiply one negative and two positives. So for greater than 0, it's this. Negative infinity, negative 2, and 6 infinity. Here we're asked to just plug in x equals 46 and x equals 61, and also look at the table. And we realized that this was an overestimate. Next section, we are using properties of logs. So first, I realized that it's a ratio, and the two factors at the top, log base b of this plus log base b of y to the fourth, but minus what is in the denominator. And power 1/3 comes in front, power 4 comes in front, power 5 comes in front. Same thing here, log of x to the fourth plus this minus this. If it's in the denominator, it has to have minus in front. If it's in the numerator, we'll have plus. Power in front, power in front, power in front, and that's it. Now we want to condense. First, we have to bring the power back. So it's natural log of x squared and natural log of the square root of y. This has minus in front, so the square root of y goes to the denominator, positive, so it goes from to the top. Here, again, the power has to be dealt with first. I put it back where it came from. And now when I see the middle part, forget about 1/3 for a moment, I see these two have negative, so they have to, their quantities have to come from the denominator. So they have to go to the denominator. This one has positive in front, it will go to the top. And power 1/3 is the cube root. Here we were asked to determine with the graphing calculator, log base pi of 400 is natural log of 400 over natural log pi, or you can use common log of 400 over common log of pi, and you have to get the exact same number. Here in the middle, we condense into natural log of a over a minus n. And then we're asked, given some information, to determine the number of weeks. Exponential and logarithmic equations. Here I change, if both sides can be presented with the same base, we should always do that. So 125 is 5 to the third, 625 is 5 to the fourth. Copy the base, multiply the exponents. And again, same base, so that the exponents have to be the same. Same thing here, change 8 into 2 to the third, change 4 into 2 squared. Copy the base, multiply the exponents, copy the base, multiply the exponents, same base, same exponents, and get that. Same thing here, change this into e to negative 2x, same base, same exponents. Here, we cannot do the same thing. We have to add 7, and then we have to apply natural log to both sides. Why natural log? Is because I see the base e here. I bring down the power, 4x plus 5, natural log e is 1. That's why it disappeared from here. And the natural log of 11,250. I have to add 5 and divide by 4. That's what I did, and I approximated it, plugging in this in the calculator. The next one is the most cumbersome because, first of all, I cannot do anything but just apply natural log to both sides. If you do not put parentheses, you are not getting the solution. So then I distribute this number, and I realize that these two have x and these two don't. This one will move next to it, and this one will move next to this one. And I change the sign. That's all I have to do. Now here I have to factor out x. So x will be this over this, and I can approximate it. I don't remember here. I think we were just asked 5 to the third equals x, so it's x equals 125. So this is a logarithmic equation. I highly recommend state the domain first. If you don't state a domain, then you have to go back and check. You have to choose one or the other. I prefer to write x plus 3 greater than 0 and x plus 4 greater than 0. When I solve and find a common domain, I realize that if the solution is not between negative 3 and infinity, you can graph these two and you'll see negative 3 to infinity. Then I will not accept. Condense, log base 6 because they have the same base, it's a plus. Log basis of this product equals 1. Counterclockwise, 6 raised to the first power equals this. I already multiplied it. I subtracted 6, I factored, I got -1 and -6, and I'll say no. No to -6 and yes to -1. -1 is in the domain, in the common domain if you want, and -6 is not. Same thing here, I stated the domain. I condensed the left-hand side, but this time is a ratio. So the log of the left equals log of the right. They have the same base. The numbers have to be the same. I set them equal to each other, multiply both sides by 3, perform all the operations, make sure that it's in the domain, and it is. Here we're asked to determine first the constant, rate of growth, the constant rate of growth, which is k, and we were given the half-life. You can go directly to the formula. The half-life will give us the k, natural log of 1/2 divided by the half-life. And we get this, and we plug it in. And then I plugged in 25,000, 50,000, 75,000, and I got these numbers. The half-life here for the aspirin is 12 hours. Again, you can determine the constant using the formula or just follow what I did here. And then you plug it in, and we are told how long it takes to get to 70% of multiplication, 70% of the original. So I put 70% of A0 equals A0, the original, times this. I divided both sides by A0, and then I applied natural log, and I got 6.17 hours. Here we're asked to find the k, which is right here. That's the k. And then we are asked when the population will double. So 2 times the original equals the original times this. So I divided both sides by 112.5. I applied natural log 2 equals natural log of this, bring the power down, and natural log e, as we know, is 1. So t equals 58 years, which is year 2068. This was a logistic growth model. We're asked what happens when x is infinity. Okay, if x is infinity, this will be negative infinity. E to negative infinity will be 0. 0 times 4 is 0. And 1257 over 1 is just 12.57. I think this is the last. No, one more problem. So we were asked here to plug in 80, and we did in the graphing calculator, and we get that. And here we're asked to determine when the percentage will be 70. We have to cross multiply first. This times all this equals 90. Then I have to divide by 70. 90 over 70 is 97. Then I have to subtract 1. 9 over 7 minus 1 is 2 over 7. Then I have to divide by 271. So I get this. At this point, I apply natural log, not before. The left-hand side, natural log e is 1, and equals natural log of this number. Don't bother with it. So x is this natural log over this. When you plug in everything in the calculator, you get 56.19 years young. So at 56, we expect about 70% of the population, if this model is still true, about 70% of the population to have some coronary heart issues or disease. I hope this helps.